Okie dokes, let's get started with Module 5, Lesson 14, Problem Set. In this lesson, we are continuing to find common units or numbers, and we're comparing two fractions. And in this lesson, we're going to be doing it with number lines, tape diagrams, and with multiplication, benchmarks, throwing the kitchen sink at you. All right, so let's get started. With number one, we're comparing the pairs of fractions by reasoning with the units, of course, using our symbols greater than, less than, or equal. So this first one is pretty straightforward using these symbols. So we're going to look at 1/4 and 1/5. Well, what is bigger, a fourth of a piece or a fifth of a piece? Well, the fourth is going to be bigger. So we've got, we're going to put our sign here. Why is it moving on me? Okay, so we got a fourth bigger. Well, if 1/4 is bigger, and this only difference here is you have three pieces, there's still fourths and fifths, so 3/4 is still going to be bigger than 3/5. 1/10 or 1/12. 12, that's a bigger number. But wait a minute, it's a bigger number, yes, but it's a smaller piece. So 1/10 is going to be bigger. And remember, when we get to D, 7/10, well, the sizes of the pieces haven't changed, so there's still tenths are bigger than 12ths. There's just 7 of them, so that's going to be bigger. So that's sort of just getting you all warmed up, and greased up, and ready to go. So here we go with number 2. Number 2, we are going to compare by reasoning. Okay, reasoning about the following pairs of fractions with the same or related numerators. Again, using symbols. Explain your thinking using words, pictures, or numbers. Problem to be or not to be has been done for you. So let's check that one out first since it's already done. They were comparing 2/5 and 4/9. And so what they did in this one, they drew two tape diagrams. And first of all, they drew the 2/5. But then they did something a little tricky here, is they changed it into tenths. Reason being that we know that tenths are going to be smaller pieces than ninths. So that was pretty tricky. And since tenths are smaller pieces than ninths, then it also you can figure out that 2/5 is equal to 4/10, and they both have 4 pieces, but the ninths are in bigger pieces. So there you go. Well, let's look at our first one here. There's 3 slices of both, but in this case we only have fourths and fifths, and we know that fourths are greater than fifths, so we can just say that fourths are greater than fifths. Fourths are larger units than fifths. I'm just going to use that. Fourths are larger units than fifths. Okay, there you go. Fourths are larger than fifths. So let's continue along, see what we can do on the rest of these here. All right, so C looks pretty much the same as the last one. We have the same number on the numerator, which means you have 7 pieces, but we have 7 pieces of 11ths and 13ths. Well, which one has bigger slices, 11ths or 13ths? Well, 11ths are going to be bigger, so that was pretty easy. And to state that, all we have to say is that 11ths are larger. 11ths are larger units than 12ths. Oops, 13ths, not 12ths. Oopsie. All right, so 11ths are larger than 13ths. All right, so let's go to the next one. And this next one is a little bit interesting because we have these mixed different units here, but I'm looking at this 6 here and the 6, 7, and I'm saying, well, if I can make that into 12ths, if I can make that 12, then those two would be equal, and then I can just look at the units. So let's try changing this 6 into a 12. Well, how do I do that? Well, I would go 6 times 2, and that equals 12. Remember, whatever I do to the numerator, I have to also do to the denominator. So let's see what happens here if I do then 7 times 2. That equals 14. And look at that. I very sneakily have changed this 6 sevenths into 12 14ths. And now they both have 12. And what's bigger, 14ths or 15ths? You're right. The 14ths are larger than the 15ths. So there we go. And I can even state that. I can say 14ths have a TH in there. 14ths are larger than 15ths. Alrighty, let's go to the flip side, otherwise known as the next page. Alright, number 3, draw 2 tape diagrams. We're going the diagram route this time. Model each pair of fractions to determine greater than, less than, or equal. Alright, 2 tape diagrams. And I guess it's pretty important when we're drawing these tape diagrams to make sure they both represent one whole, at least in this case. These fractions are not greater than 1. And this one, and make sure that they're both the same length. So whatever length you make them, don't make one bigger than the other, because then it's going to be hard to tell which one is greater than or less than the other one. So make sure they're approximately the same length. The first one's going to be 2/3, and give it your best shot. 2/3. And the other one's going to be 5/6. Well, I'm going to take this third as a guideline to cut into 6. So if I use these lines, basically continue those lines down and then cut them in half again, I'm going to have 6. Okay. And we're going to have those tape diagrams. So let's see, we have okay, so we have over here, we've got 2/3, and then we have 5/6 over here. 1, 2, 3, 4, 5. I think it's readily apparent, or pretty clear, by looking at these two, that which one is bigger? Well, let's see. This one here is this is 2/3 right here. This is 2/3, and this right here is 5/6. Now you could also notice something. You could actually have to do this for this problem, but you could change this into 2 times 2 and 3 times 2, and that would be 4, 6. And see how all these things work together. Multiplication and the tape diagrams. If we did it, look at that. 1, 2, 3, 4, and this one's 5, 6 down here. So, getting back to our original, what we need to do is put our symbol in there. Well, which one is bigger? Is the 5, 6 is bigger. So, all that work for that, but it's showing how all these things are related. All right, I'm going to press the pause button and let you ponder the next one a little bit, and pretty much do exactly the same thing we did for this one. So go ahead and hit pause on the video and hit play when you're ready. Okie dokie, how'd you do? Now, if you look at this, Again, you could convert the 3/4 into eighths, and you could see then that you have 1, 2, 3, 4, 5, 6 eighths, and 7 eighths is going to be more than 6 eighths. So again, this is just putting all these things together, because we could do 3 times 2 and 4 times 2, and then we get 6 eighths. 6 eighths here, and of course 7 eighths is going to be more than 6 eighths. So again, it's just putting it all together. And then for the last one there, the only difference there is you have to draw 2 tape diagrams. You have to draw the one whole, and then you have to then draw the fractional part. So let's see what we do here. So we're going to start off with one whole. They both start off with one whole. Okay. Both of them have one whole to begin with. Okay. And then they have 3/4 on one of them. So one of them is going to be split into 3/4. Okay. And the other one's going to be split up into 7/12. And you're supposed to figure out which one is bigger. All right. Pause the video. When you're ready, check your answer. Okay, so, well, I drew the tape diagrams, but what's the answer? Well, it looks to me like 3/4 is greater than 7/12. And you look at this and you go, whoa, I could do some multiplication here. I could change that 3/4 into 12ths. All I'd have to do is times this, or cut these into 3 pieces each. Look at this, look at this, look at this. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is equal to 9/12. Well, we could do 3 times 3. If you don't know where I'm getting that times 3, it's because I split each one of these fourths 3 times and made them 12s. So that's 9/12. 9 is bigger than 7 all the time. All right, catch you on the next flip side. All right, welcome to the final flip side. This is a pretty long lesson here. All right, so in this next one, number 4, we're going to draw a number line, model each pair of fractions, and we're going to use our symbols again to compare. So it's number line time. Number line time. We're going to plot them both on a number line. All right, let's do this. This first one here, we're making a number line, and we're going to start it with, this is going to be between 0 and 1. I know that because 0 and 1, because these fractions are less than 1. And 2/3, so I'm going to have to guesstimate thirds on this one. So it's about a third, that's about another third. And one of the points is 2/3, so I can go ahead and pop that on there. 2/3 would go right here. That's 2/3. And then what about 5/6? Well, if I split these in half again, bam, 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 now I can count 6. 1, 2, 3, 4, 5, 6 is right here. 5, 6. And some of you would say, well, you could change 2/3. That would be 4/6. So this is also 4/6. 5/6 is more than 4/6. So 5/6 is definitely bigger. All right, once again, pause the video and try those on for size. All right, I hope the size fit. In other words, I hope you got them right. In all these, most of these you could split down further and use even multiplication. If you look at B, if you change the fourths into eighths, the 1/4 would become 2/8. Okay, and so this 1/4 is actually also 2/8. Okay, and on C, the 2/6 could also be known as 4/12. So you can see the relationship there. And then in the last one, the 2/3 could also be known as, well, let's see, 1, 2, 3, 4, 5, 6/9. Okay. Just keeping all these relationships, multiplication, number line, close to one whole, all these things, keeping all these things in mind. And in the last part, in number 5, or next to last part, number 5, you're going to compare the fractions, and you only need to use a model if you choose to. Okay, or you could use multiplication or any strategy you wish. So let's look at the first one, A. Okay, 3/4, 3/7. Well, I know that these are the same number of pieces, but fourths are bigger, so that's easy enough. B, well, let's see. For B, what I could look at this is, well, 4/5, that's really close to one whole. Or I could even change this times the numerator by 2 and the denominator by 2, and I would get this. I would get 8/10. If I do that over here this time, 4 times 2 and 5 times 2, that equals 8/10. Well, 8/10 are going to be bigger pieces than 12, so there we go. I just did a little multiplication. I like how that works. So go ahead and hit the pause button and finish these in this section. All right, check your results on those. And some of them I gave some little explanation. I like to change common numbers if I can, so that I can see whether my numerator is equal or my denominator is equal. But check your answers and see how you did, and there's one more to go. All right, in this last problem, we're talking about the diagram that Timmy drew on the right, and he claimed that 2/3 is less than 7/12. Now that's what Timmy thinks. Even Drew says he thinks 2/3 is greater than 7/12. Well, who's correct? Support your answer with a picture. Well, let's look at this. Who's correct? Well, what we can look at here with this picture is that, well, for the picture, it appears that 7/12 is bigger, but let's do some multiplication to figure this out. If we have 2/3, okay, and then we could change that into 12s. Well, how would I do that? I would multiply the numerator and the denominator by the same number to give me 12s, which would be 3 times 4 and 2 times 4. So 2 times 4 is going to be 8, and 3 times 4 is going to be 12. So actually, who is right? It is 2/3, because this up here equals 8/12. So even though the picture appears that the 7/12, why is that? Because look at all these over here are real skinny. Okay, so pictures can sometimes be deceiving. So I'm going to say that let's see, Evan is correct. Evan is correct. And I supported it with, well, looking at the picture, I did talk about that, but I actually supported it with straight mathematics and multiplication. Now you could write, well, the picture, the 12ths, all these 12ths, the 12ths he drew here are bigger. They're larger. They're not all equal. So hit in Timmy's picture. Okay, I just added. In Timmy's picture, the 12s are not all the same size. And there you go. So you got to be careful when you draw pictures, because sometimes pictures can be deceiving. And with that note, I know this was a pretty grueling lesson today, so hopefully it helps with your homework, and I'll catch you next time, same place. Hasta la vista, baby. Hey, you know the drill. Get to work.